So number 41 is you can see it's again it's a repeated question, so we are going to mark it directly, which contains only scalar quantities. So kind of repeated question in which distance, mass and speed are uh, are scalar quantities. Number 43. So you know that in case of micrometer, we will measure from here 5. This one would represent 5.5, 6, 6.5. So our reading is 6.5 till here. Now circular scale reading. Circular scale reading is 10. This one represents 11. This represents 12. And this one is 13. So 13 divided by 100 is 0.13, and we are going to add it here. It would become 6.63. So our correct option is this one. Question number 44 is again a repeated question, so we are already done with this question. So thickness is in kind of mm's, so we are going to use micrometer for this one. Width is in centimeters, so we are going to use Vernier Caliper for it, and this length was in 40 centimeters. It's 40 centimeters. For that we are going to use meter ruler. So for length, meter ruler is here and here. Thickness is micrometer and micrometer, and for width, Vernier Caliper is here and here. So overall this option was correct. So in question number 45, it's a Vernier Caliper. So let's see where is the main scale 0. Vernier scale 0 is here. So Vernier scale 0 is here. Okay, so if we go here, it's 5 on main scale, it's 4 on main scale, and it would be 3 on main scale. So Vernier scale 0 is in between 3 and 4. Vernier scale is in between, Vernier scale 0 is in between 3 and 4. 3 and 4 on main scale. Now see, on the main scale, it is already in millimeters. So our reading would be 3.0 plus. Now see here, the 5 of main scale and Vernier scale are parallel to each other, or you can see are matching or coinciding. So 5 divided by 10, it would become 0.5. So 0.5 would be here. So overall reading would be 3.5. So correct option looks this one. Which of the following correctly lists one scalar and one vector? So displacement is a scalar quantity, we know it very well. So I'm going to mark only scalar quantities. Force is a scalar quantity, velocity is a scalar, oh sorry, force is a vector quantity, sorry, I don't know, let me redo it. Scalar quantities, okay. Energy is a scalar quantity, displacement is not a scalar quantity, force is not a scalar quantity, velocity is not a scalar quantity. So now let's move to vector side. Work is not a vector quantity, mass is not a vector quantity, force is a vector quantity, acceleration is a vector quantity. So you can see this is our correct option, because energy is a scalar quantity and force is a vector quantity. Number 47. In an experiment, a ball is rolled down a curved track that is about half a meter long. Which measuring device should be used to measure the length accurately? So for length we know that either it's a half of the meter, so we can use meter rule, and measuring tape. Actually the curved path for curved measuring tape is more better option than meter rule. Question number 48. The diagram shows a Vernier scale. What is the reading on Vernier scale? So see, so this is the zero of Vernier scale, and it is, suppose it is 6.1, this one would be 6.2, 6.3, 6.4, 6.5 and 6.6. so reading is in between 6.5 and 6.6. so original reading is lying in between 6.5 and 6.6. so now see this one, this line of Vernier scale is matching with main scale. So this line is 0, 1, 2, 3, 4 and 5. So the fifth one. So how do we write the reading? It is 6.5 because it is 6.5 and there the fifth number, so we will put 5 over here. So this is the correct option. So in number 49 it says calculate the diameter of the diagram shows one method of measuring the diameter of a beaker. So diameter is actually from here till here, so we need to find the length from here till here, and in between them the length would be somewhere like this. This would be the diameter. So what we are actually going to do is, suppose this is, see the pattern, it is 0, it means it is 0.5, then 1, it is 1.5, then 2, 2.5, 3, and this is 3.5. so our starting point is 3.5 and our ending point is 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5 and 8. So our ending point is 8. So it starts from 3.5 and ends at 8. So so now let's calculate the difference between 8 minus 3.5. It would be equal to 4.5. So our option is A. In number 50, a student studies some equation. Power is work done per unit time. Okay. Force is mass into acceleration. That's fine. Velocity is distance over time. That's fine. How many vector quantities are contained in equations? So okay, power is not a vector quantity. Time is not a vector quantity. Work is not a vector quantity. Mass is not a vector quantity. Time is not a vector quantity. So we have force as a vector quantity, acceleration as a vector quantity, velocity as a vector quantity, and displacement as a vector quantity. So there are 4 vector quantities. You can see the number of green ones. Number 51. Which instrument is used to measure the internal diameter of pipe with a single measurement? We know Vernier Caliper is the most suitable thing. Which is the correct statement about force and velocity? Force and velocity both are scalar quantities. Wrong. Force and velocity both are vector quantities. Yeah, looks fine. Force is a scalar. Wrong. And velocity is a vector. Correct. Force is a vector. Correct. And velocity is a scalar. Incorrect. So we have only one correct option, B. So number 53. The diagram shows a vernier V placed against a scale S. So here is like the smaller one is vernier scale and the large one is some type of scale. What is the vernier reading? So let's see what is the reading. So first of all we would find the 0 of vernier scale, which is here, and then we will find out the reading of main scale. Okay, so it is 2 and here is 3. It means it would be 2.1, it would be 2.2 and it would be 2.3. So and here is 2.4. It means the 0 of vernier scale is in between 2.3 and 2.4. So this is our first stage. So we know that we don't care about this second reading, which is 2.4. So we would only consider this one. So 2.3, and here would be the next number. Okay, so now we are going to consider the matching line, like the main scale reading, like the Vernier scale and main scale matching line. See, these two are kind of lines, like this, the line of scale and Vernier scale both are matching. So let's count what is the number of it. So 0, this one is 1, 2, 3. So it means this is our reading for this scale. So our correct option is C. So C is our correct option. Now number 54. Number 54 says a student has been asked to determine as accurately as possible the volume of piece of wire. The wire is 80 centimeter long. It means we can use meter rod, meter rule, and about 0.2 centimeter of diameter. It means micrometer, and it's for this we can use ruler. So let's see what is the correct option. So for length, meter rule, diameter is micrometer. So this is the correct option. Again we have a main scale, like some type of scale, and then Vernier scale. So the diagram shows part of Vernier scale. What is the correct reading? So you can see the Vernier scale 0 is here, so it is in between, like this is 36, oh sorry, 30, 31, 32, 33, 34. So it is in between 33 and 34. So this 0, which is Vernier scale 0, is in between 33 and 34. Okay, so keep in mind the scale is in millimeters. So it is in between 33.0 and 34.0. So we don't care about this number, we would only consider this one. So now next thing is which line actually match exactly with the see, Vernier scale line number 5 is actually matching with this line, so it would become 33.5 mm. So our correct answer is this one. Number 56. See, again similar kind of question. The Vernier scale 0 is here, so you can see it's 6, it would be 6.5, it would be 6.6. so Vernier scale 0 is in between 6.5 and 6.6. So actually we don't care about this number, so our answer would be it is in 6.5, and by keeping the rule for centimeters. So now we are going to search out the which line actually match with the, oh, see this fifth one. So fifth one is actually matching with the main scale, so we are going to put 5 here. So our answer is B. Which of the following group of physical quantities consists only scalar one? So let's consider the scalar one. So I think it's a repeated question. It is already done. So mass, speed and time are scalar quantities, so D is correct option. So one oscillation of swimming pendulum occurs when the bob moves from X to Y and back to X again using a stopwatch. Which would be the most accurate way to measure the time of one oscillation of pendulum? So we know that it is quite difficult to measure the time for a single oscillation. So it is better to measure the time for more than like 10 or 20 oscillations and then divide it with 20. That will give us the time period for single oscillation. So let's see which is the correct way. In option A, 20 oscillation multiplied by 20, false, because 20 oscillations and then multiply 20 makes no sense. 20 oscillations and divided by 10, that looks fine. Time of 20 or time of one oscillation, like there is an error, like the error may be due to, it may be an it may include human error, like stopwatch, like press, like the time taken to press the button is also a kind of error which actually extends the time of oscillation. No, that's like the D option is not fine. So our answer is answer B.